What happens when a wire connects directly across a power source with almost no resistance? And what happens when a circuit is completely broken so no current can flow at all? In this video, you'll learn the two extreme conditions in circuit theory, short circuits and open circuits, and why they are critical in both analysis and real-world failures. A short circuit is a condition in which 2 points in a circuit are connected by a path with extremely low or nearly zero resistance. In theory, this means current can become very large because there is almost no opposition to flow. In real systems, short circuits are dangerous because they can cause overheating, component damage, or even fire. An open circuit is the opposite condition. It occurs when the electrical path is completely broken, meaning resistance is extremely high or infinite. In this case, no current can flow through the circuit regardless of the applied voltage. Open circuits are often caused by broken wires, switches in the off position, or failed components. These two conditions represent the extreme boundaries of electrical behavior. Understanding them helps engineers quickly analyze whether a circuit is functioning normally or has a fault. In a short circuit, Ohm's law explains the behavior clearly. Since resistance approaches zero, even a small voltage can produce a very large current. However, in real circuits, this current is limited by internal resistance of the source and other components in the system. This excessive current flow generates heat due to power dissipation. Because power is proportional to the square of current, even small resistances can produce significant heating under short-circuit conditions. This is why fuses and circuit breakers are used to protect electrical systems. In an open circuit, resistance is effectively infinite. Even if a voltage source is applied, electrons cannot complete a closed loop, so no steady current flows. Any measured current becomes zero because the path required for charge movement does not exist. A short circuit can be imagined as a highway where all barriers are removed and vehicles can move without restriction. Traffic becomes uncontrollably fast and chaotic because there is nothing limiting movement. This represents how current behaves when resistance is extremely low. An open circuit is like a road that has been completely cut off or destroyed. No matter how many vehicles try to move forward, they cannot reach the destination because the path is broken. This represents a circuit with no closed loop for current flow. These two analogies help highlight the fundamental idea. Short circuits allow excessive flow, while open circuits block flow entirely. Real circuits must always operate between these two extremes. In engineering practice, short circuits are considered fault conditions that must be avoided. They can occur due to insulation failure, wiring mistakes, or component breakdown. Protection systems such as fuses, circuit breakers, and current-limiting circuits are designed specifically to handle short-circuit conditions safely. Open circuits are also common in troubleshooting scenarios. A broken wire, disconnected connector, or failed solder joint can create an open circuit condition. Engineers often diagnose open circuits by checking continuity using measurement tools. Understanding both conditions is essential for circuit analysis, safety design, and fault diagnosis. Many real-world electrical problems can be quickly identified by determining whether a system behaves like a short circuit or an open circuit. In household electrical systems, a short circuit can cause a sudden surge of current that triggers a circuit breaker. This prevents damage to wiring and reduces the risk of fire. Devices are designed with protective elements specifically to handle such conditions safely. In electronics, an open circuit often appears as a failure mode, where a device stops working completely. For example, a broken trace on a PCB or a damaged connector can interrupt current flow and disable an entire subsystem. Engineers use multimeters and continuity tests to detect open circuits during debugging. Identifying whether a fault is a short or open condition is one of the first steps in electrical troubleshooting. So today, we learned that a short circuit allows extremely high current due to very low resistance, while an open circuit completely stops current flow due to broken connectivity. These two conditions define the extreme limits of electrical behavior and are essential for both circuit analysis and fault diagnosis. In the next lesson, we'll explore energy loss in circuits and understand how electrical energy is dissipated in real systems. If you found this useful, like the video, subscribe, and follow for the next lesson.